First of all, good morning. Thank you for coming out. My name is Pierre Du Bois. I am the founder of Zamana Analytics. Thank you for coming to Code PaLOUsa. And I'm going to talk a little bit about workflow with R programming. But first, I'm going to give you a quick overview of who I am, and then we'll get into the slides a little bit. I am an analytics specialist. I've worked as an analytics specialist now for about coming close to 12 years. I started off, my business is called Zamana Analytics, and I work with medium and small businesses that have analytics data, but not enough time to do the analysis to figure out what they are doing. And most of it centers around digital marketing. We started off using Google Analytics, and we still use Google Analytics and a lot of the some of the tools associated with it. But over the past now, about maybe not quite 5 years, but at least 5 years or so, we started to use R programming because of the needs of exporting data. And then I'm also a contributor on digital marketing. You can find me on Medium. I actually started writing articles for Medium just recently on a couple of platforms. But I've been writing for CMS Wire for about 6 years. And then UBM Tech, which owns Information Week, I've been writing for them for the last, oh gosh, now not quite not quite 6 years or 7 years, but close to it. So I'll post up the slides. I'm sure you've seen this before, but I just want to give a quick shout out to the amazing sponsors for Code PaLOusa. Again, Amazon Alexa, Software Guild, Andromeda, and Modus. I want to say thank you for them for sponsoring this event and keeping us going, particularly as everyone works remote. So let's get over a little bit about what we're covering here. So this is supposed to be a let me quickly ask here. I'm going to flip over for a moment. How many of you are using R programming right now? And I'm going to flip over, and you can type it into the session chat. If you can give me an idea of, if it's very recent or if you've been using it for quite a while. Most of these slides are really kind of getting into a little bit of organizing about, it's more about approach with data. A lot of times with programming, no matter what language you use, you tend to get stuck with just all the terminology, all the functions, and there's extensions. But okay, so Jody says not actively using R personally, but my company does. I'm slowly getting involved. Okay, good. A lot of times there's a lot of discussion starting an R course this week. Okay, Megan. Okay, good. Let's see, if Dylan, if you want to join in, and Aaron, if you want to join in a little bit, I'll give you guys a couple minutes to type your response. So what I did with these slides is kind of give an overview of how to approach data in general. They're based off of a slide deck, not using R, never used it. Okay, great. Okay, so this is perfect. So what I've done with this is to give an overview of how to approach the data within R. It's not radically special in terms of, in comparison to Python. You'll hear R programming and Python together. Those are the two big languages, with Python being very, very popular among developers and R being very, very popular among data scientists who are playing in a different industry. And both languages are valid. In fact, RStudio just announced a variation. They just announced that they now can run Python in the IDE. So that's relatively new. But the idea with either one is that most people are interested in the data and taking it and making a model. And in most cases, you're trying to kind of get a little bit of a flow of where to start and how to form. So I kind of made these slides to get into the very basics of it. There's a little bit more in terms of pipelines. You'll hear a lot about containers as you advance further and further. We won't get into that with the slides, but this will tie into this audience if you're just starting out, just to kind of help you on where to organize. And that's kind of how I've approached this. So, so the idea is kind of give you a workflow. In R, you have what's called libraries. These are extensions that are designed to give you functions within R. There's some basic functions in R for statistics. That's what R programming has been very popular and used for. Same thing for Python. But sometimes you may have specific statistical models you're trying to make. And there are quite a few that are built for Python. TensorFlow, which I presented on yesterday was there's a huge uh, uh, there's a huge community that's been built around TensorFlow based on Python, but now you have other languages that have picked that up, and those other languages are using extensions as well. So the idea with libraries is that you may have particular statistics that you're trying to apply to your model. And we won't get into it too deeply, but there are some libraries in R that can help you in terms of organizing. And then we'll give you some ideas about how to examine the data to get your model started, and some general ideas for maintaining a workspace. So I won't get too deep into this. So this is, again, R is an open source programming language, and it's used for statistical models. You're taking data from Excel, maybe from a CSV file, and these days from a database, and then importing them into R, and then you're running and creating a statistical model. That's kind of the general idea. R was created originally for files, but over the years, as you probably imagine, we have more ways of importing data from a database, and people have come up with libraries to allow you to do that. And we'll talk about that in a moment. There are a lot of IDEs that are used for R programming. The one that's most popular that you'll hear about is RStudio. That's a company, I'm not even sure where they're based out of, basically, but they're probably the biggest and most popular. The reason why is that you get with RStudio, you get 4 panels. R is supposed to be run in the terminal within your Windows or your Linux or your Mac. But what happens is that you kind of have this one window for running everything, and that can become cumbersome if you're trying to go back and figure out where your data is sourced. You might want to look at the number of objects that you have within your program. You need something that takes you out of one window and to have like maybe multiple windows that lets you do a little bit of checking and make it easier. So that's what the IDE is about. What you see here is just a quick screenshot of RStudio. The top left is the terminal. Lower left is the console where you can take a look and see what's going on maybe in a file. And then you have what's called an environment and history. That's in your upper right. And by the way, you can move these around within the IDE environment. But the idea is that you have these sort of windows that help you to see where your data is coming from, and help you kind of see what objects that you've imported or created within your files. Now, there is a Microsoft Visual Studio Code. It can be used as an IDE, and there are extensions for that as well. I have not tested those through, but I know that there's extensions that will allow you to run R and do coding. So if you're into Visual Studio Code, that can help you quite a bit. But most videos, to be honest with you, if you're starting out, to be honest with you, even if you're going back to YouTube, you're going to likely find someone using RStudio. That's kind of the most popular. Now, it's typical to start a R project by just opening up an R script. Every file that you save usually has an R extension to it. So if your name.r, that's usually a file. An easier thing that you might want to consider is starting with a project when you're using it. And the reason you want to do a project is that, and don't get me wrong, doing 1 or 2 scripts may be fine. The problem is that you may have data files that you've imported. You may have documentation that you want to keep within one folder. And it may be easier to have that within a project. So one of the options that you want to think about is starting with a project. And that's just, again, you'll see that in the menu along your selections when you choose to save and open files and so forth. So it's not anything radically special. The extension for it, I believe, is I think it's PROJ, if I remember correctly. But the idea is that it's basically a large file that can hold your scripts, maybe some documents that you want to add to it later, and then databases that you later may want to call within your script. And the advantage that you get from that is being able to, if later on if you choose to share your information, you can now have just one project that you can share a little bit more easily. Plus, there's also ways of saving a project as a Markdown file as well, too. We'll get to Markdowns at the end of the presentation. Oh, and there's one thing too I'll add. You also can save a file as or save a project as a GitHub with a GitHub repository. So this may be helpful. This is an option basically. It's not a mandatory, but if you're already using GitHub for, let's say, maybe other languages, or if you're a developer that you've already you're accustomed to using GitHub and you want to make it easier to share into a repository, that is possible. And you can do that for version control. Now, one caveat of this is that you need to set up your repository first. And then when you navigate into GitHub, you copy your HTTPS URL, and then you go into your project within RStudio and set up the URL and project name. And so the idea with this is that you are, I apologize for that. What you're trying to do is that you are, it allows you to basically set up a repository to have with your project, but this is not mandatory, but it's helpful to you if you're using GitHub already. Let's see, make sure I'm not, and by the way, if you have questions or anything else, make sure that I'll flip back and forth between here and the slides. I have my slide deck in Chrome right now, one of the tabs, but if there's questions or anything else, I will make sure that I'm going back and forth between the chat so I can see that clearly. So feel welcome to ask, and I'll try to catch it as we go along. So now that we got a project, the next thing you want to think about is maybe a data structure. And again, this is kind of give you just, organizing, where your data is being sourced. Is it coming from a file, an API, or URL? What type of data exists within the fields? Is there a header or not? That can dictate what gets imported into your model. And then the data object fields, they should ask the question of, what is it that you may need to do for maintaining some sort of cleaning on the data. Most people, when they use R and Python, they do a lot of, if you're doing data science, half the time you are setting up, you're doing a little bit of cleaning of the data itself, and that just means setting up the variables and the observations of those variables such that it's easy to, if you know that you have to repeatedly update data, it's easy to import and not make too many changes into your data model or your calculations. That's pretty much the general idea. But there are tools that will help you even before you get to that point. There are dataset repositories, and these are different sources of data that you can import. And the data from here can be for things ranging from city size and population to different types of trends. Some of these are from sources like Pew Institute, healthdata.gov, which has health data for you. Now, these you may not necessarily need this type of data, but the reason I'm highlighting it is because some of the repositories, what's happened in the last couple of years is that they allow you to not only do a search for different types of data, but you can also take a look and see get a preview what's going on. For example, the one that I particularly like is called Data World. That's what you see here at the bottom, basically. What Data World will allow you to do is to search for Excel files, CSV files from different sources or things of data that you can play around with. And what the neat things about it, and you can see this in this image, is that it will allow you to kind of get a preview of what the column headers are and what sort of observations are in the columns. So it kind of gives you an idea of what you may be downloading before you download it. Now, the one in the upper right is from the city of Chicago. And the reason why I highlight this is that going back to maybe 2016, 2015 or so, what a lot of municipalities started doing was to encourage more developers to come up with apps that would help for city services. They came up with what's called a data portal. And so a really good example from the city of Chicago was a gentleman. I don't know if I think he stopped his app maybe a year or so ago, but it was a really cool idea. He used weather information combined with beach condition information from the city of Chicago to come up with an app that would tell people when it was great idea to go to the beach. You called it Drek Beach, which was, I think if I remember, I think it was a Yiddish word for crap, basically which is what Drek is. But the idea was that you now have an app that can help you understand what the conditions were at the beach and even report it to the city of Chicago. So a lot of the cities in trying to compete against Silicon Valley came up with these sort of city portals. So, but the point is, there's different types of data repositories out there that you can look for if you're looking for data that might help you for your model. But let's say that you already have data. Well, there's a lot of different functions that can help in terms of importing those data in. Make sure I'm not missing any questions. Okay. So the idea is that and some of these you'll see with R quite a bit. There's a read function. There's a read for CSV, for table files. And then there's actually a library called Reader, READR, which allows you to read not only different types of data, but also different types of text files. There's another library called XLSX, which can be used for Excel, for example. And the example that you see on the screen right here, this is just a file that just kind of shows how this would look like. Each time that you're importing data, what you're doing is that you call this function. I don't know if you can call this function on line 26. There's a you see where it says diaprod. That's just a name for a variable. And it's basically an object within R. So think of it as a container, and then you're assigning it the function read CSV, and then within the parentheses is calling the name of the file. And again, going back to what I was talking about with project, what you do is a lot of times you want to be able to have these files. If you have a file, it should be in the same directory that your home directory that you're calling from. So the idea is that you can, when you call that data, it pulls it in, and then when you call the object, you can go back and see, as you can see right here, this is for diamond production from different countries in the millions, and you can see in the header you got the year and then the country going into that first column. So it kind of gives you pretty much a way of importing data in if it's just coming in from a file. Now, let's say that you have it coming from a database or something a little bit more complex. There are some libraries that can help you to do that. And within R, there is a site called CRAN, CRAN.org. This is a repository for all libraries within R, and this is where developers publish libraries, and then people can come and download them into their RStudio IDE or download it as a zip file. And if it's a database, something like a MongoDB, something like or something like an application, like something that might a type of file like a SAV file that works with SPSS. There's usually a library that's associated with it that makes it easier to import or not only import files in, but maybe even export. So just a couple examples here: Haven, which allows you to export to SPSS; RMongo, which is accessing in a Mongo database. If it's a JSON file, maybe the type of structure to it. There is libraries for that, JSON Lite. So I would say if you know what type of source or data or structure that you're using for, you may want to check in CRAN if there's a library available for that. Chances are there is. Now, let's say that you're coming from an API. Well, there is a library within R, or library you can download from CRAN called HTTR that allows API data to be imported into an object. So in this example, you can look and see right here on line 8, there's we have a object that we are assigning to an API or URL basically. And then the next line, you have a object which takes that query object, and we use the get function. And that get function basically is connecting with that API to draw that data in. And then you can run that object to kind of see what data is there. Now, there are some additional functions that you can use to help see what structure is in the object, like structure. STR, and that's in parentheses. And there's also content as well too. And there's also another one called header, which lets you see the headers that appear from your query. So this is a way of importing data as an API. Now, one of the things you want to keep in mind is that some libraries will have maybe keys that you need to get, and these are just basically these are standard keys that you would have for your API. So this one has an example with this is a library called RGA for Google Analytics. So one of the things that you want to keep in mind is that if you need to get keys and attributes, definitely check and see what's available in your API. And then a lot of times these libraries will allow you to enter those keys and that code in there. So that way you can also pull data as well. So we talked about setting up projects, talked about importing data. Let's talk a little bit about some of the functions and features for what we have for data. So there's and we won't go through all the functions available, but we'll go through a couple of key ones. And what most people tend to do with R is that once they have the data imported, they start looking and seeing what's in the observations, how they're arranged as columns. And so there's a couple of base functions within R that are helpful for this. Head is one of them, which returns the first several rows. Tail, which returns the last several rows within an object. And you can't indicate by number how many rows, if you want to extend it more than several rows or a few, basically. Dimension and summary can give a few statistical details on those observations, but there is a library called Dplyr, DPLYR, that allows you to see a little bit more. It does it in a little bit in more organized way. So you'll see that mentioned here throughout the presentation. So one of the functions that is really useful is one called glimpse. And so what that does, and you can see right here on the slide, it basically allows you to see the number of observations that may be appearing within the data, and then the number of variables. The variables are basically, think of it as if you're doing a regression, they're basically your columns. So the idea is that you are getting an idea of what columns are there, and it might give you some ideas of what you might want to set up for correlation and what you want to look for in terms of maybe even building a regression, for example. So that's pretty much what the benefit is from using a glimpse. Now, this is not my favorite slide, basically, but I'll explain a little bit about the squares here a little bit. R has basically there's 1, 2, 3, 4, I'll say 5 different structures basically for an object. If you're talking about a vector, a matrix, and most of these are data frames and data tables. And I need to explain a little bit about what's going on here. So basically, the way that R operates is that you have if you have multiple objects and multiple variables, you have different types of objects that can have different types of observations, depending upon whether or not those observations are nominal or something with characters, for example. So, like, for example, a vector is a column with one data type. So if you can imagine, I'll scroll back up here for a second. So if you can imagine, let's say the year of our example here, we have, obviously you're going to have numbers. You're not going to have maybe text or what have you, but you're really going to have these you may be treated as numbers basically. Or let's say a displacement. This is on automobiles. So actually, let's say horsepower. That's a little easier to. Let's say horsepower. You have numerals for horsepower, basically. So in a vector, what you want is something that shows one type of observation, whether it's numerals or characters. A list is like a vector, but it's going to be mixed. It's usually one or more different data types. Then a matrix will have it's pretty much a table where you have very much one type in every the same type in every column. But a data frame and data table I'll explain these two are kind of similar. They're pretty much close cousins. Each one of these, imagine a column where one column has one type of data type, another column has a different data type, and then another column has a different data type. So going back up here, for example, overall in this data frame X, we have different. You have one set that is a character type. You can see that with make. But then if you went to horsepower, you see that's an integer. So you have basically numerals that's there. So what it's saying is that we have 13 columns, but in each of those columns, one column has characters, another one, and a few columns have integers. So it's pretty much like a data frame. A data table is very recent within R, and it's just sort of it's, to be honest with you, the differences are probably a little larger and longer to go into. But it's basically it's just basically just keep in mind that you want columns, and in each column you want to have a particular data type. And most times when you're building a data model, that's what you want to go for. So that means you need to consider what makes up an observation, what's going into the data fields. So you need to have some ideas about what needs to be inspected, and that's just basically, that's what's based off of your knowledge base of what's in the data. Develop your model simply at first, and then you may want to, if you're doing something like you want to think about the guardrails that you want to put up, particularly if you're going to do something with statistics. You want to consider the possibility of something versus the probability, but you want to do it in terms of logic. Like, for example, here, are negative miles per gallon possible from a car? And the answer for that would be no. There's no. So if you had a range of data to check in your model, you definitely would want, your bottom starting point would be 0. And let's say that that there is a threshold that you're trying to meet for MPGs. It would be that 0 to threshold. That's an example of a guardrail. It's the idea that that there's no such thing as a negative miles per gallon. Another example to keep in mind is thinking about, is a not available from a self-reporting observation possible? And this just means that if you have data from something that is from a study, a survey, is it possible that someone can put in, let's say you have numbers, for example, scoring, is it possible for somebody to put a entry that has a NA in it or something that's null? The reason being is that you may want to think about how those things are going to be treated for your model. Some of the models within R are really not designed to have not available or a null in it. And you'll see that for something in terms of machine learning for more advanced pieces, but you want to be able to identify that within your data. And that's something you can use within R to do, is to help identify. And we'll get to that in a moment. Let's see. Make sure I'm on time. Make sure you're asking some questions. If I'm going too fast, too slow, type it in there, say, hey, Pierre, this is great, or hey, Pierre, this is not great. Okay. So you want to ask how different values exist, how many different values exist in a column. Glimpse can help you for that. Are there any duplicate values? You want to think about, this is where you get into, this is the data cleaning part that you want to get into. Are there anything with duplicate values? And you can, by the way, for anything with duplicate values, you can use, if you're using something like Data World, some of those data sets I've shown to you earlier, some of them do have features that will let you kind of quickly identify those as well. But R is really good at large data sets and capturing, like, if you have like a large number of duplicate values, it's very good for automating that and capturing it very quickly. And then, are there missing values? Is it NA, null, or just maybe some missing text? And then the one thing you want to keep about is, does the ID of an observation have a match in another column? In other words, are you dealing with data where there's some sort of ID that has to be matched to maybe some other description in a column? Those are things you may want to keep in mind, particularly for machine learning. You want to keep in mind because for things like bringing up with TensorFlow, you may need to transform some columns into headers and treat those a little differently. But we won't get into that too deeply here, basically. But there are some instances where that has to come up. Okay, so to view observations within data, you have a couple ways you can. This is pretty simple, so I'm won't go through this too deeply, but you basically can call up at the prompt, whether it's a column, whether it's whether it's a row, basically what's in those rows. If you need to see one or two rows, basically, or one or two columns, or if you need to see an actual observation within a data set. And then one thing you want to keep in mind too, real quick with R, is that R has a little bit of a treatment in terms of null. It basically, if you're looking at the length of observations, anything that looks at a length, if it's an NA within the array, basically, or a list, it's considered an observation, just like it would for a number. And that's what the example you see here, 4, 5, 6, and then NA is counted. So if you went back, this is kind of a great view here, but if you went back and assigned, let's say, a list to an object, and you call that object, NA would show up. If there's a null in your data, it's not considered an observation, and it's actually, R doesn't count it. So again, this is also why you want to look at NAs and nulls and just kind of make sure that if you're doing something that's counting the number of observations in your data fields, that can throw off a little bit in terms of, if it's a null in there, it can throw off your count, or if it's an NA in there, it can throw off your count, depending upon how it's called. So there's a couple of tricks you can do within R. The easiest is a function called is.na, and then the name of the data set. It will show all the observations where an NA exists. But this is set up by itself. It just kind of gives you sort of a binary response. It would either say false or true in each observation. So if the data set is very small, so basically just saying that yes, there's an NA in it, no, there's an NA in it. But just from that previous example, you may be more interested in the number of which ones have which observations has that NA or null. So what you can do is do a combined function, any in parentheses, and then put in the is.na data set. So the idea is that by doing that, you can have that can actually take that back. I just like, okay, let me back up a little bit. I just explained this backwards. I just realized is NA data set will give you all the observations when an NA exists, and then any is NA data set will yield a single true or false. So that any is, I would start with that first to just see if it's in there, and then go back and do is NA data set to see where it is within the observations. If that makes sense. And then another function that you can add within R is called it's called funModeling, and it's kind of an odd name for a check, to be quite honest with you. But you can use it for identifying the number of zeros, and then also the number of NAs in a data set, and it returns it in a table format. I'm going to make an adjustment on this slide here a little bit, so that way you can see a little more clearly. But what it does is that it comes, just like glimpse, it comes back with a number of data pieces of results on an object to tell you the quantity of NAs that are in your data. It actually gives you a percentage, which is really cool. The quantity of infinite values, which may be important to your calculations. The type, and the quantity of unique values. So it kind of gives you a little bit of an overview of if you have zeros, NAs, and if there's something that's repeating within your data set very quickly. So far we've looked at a project. We've looked at importing data. We looked at the number of observations. Now what we want to do is get into looking at some of our rows and columns. And so this is where there's, again, some built-in functions, and this is where the function Dipler can help us in kind of getting into rows and data. So the rbind and cbind can help you if you're trying to combine a row or bind some data together. But there may be some instances where you might want to cut out a section of data from your data, particularly if it's a data frame or data table. And that's where Dipler can come in to do that. Dipler provides a couple of functions, slice and filter. Slice is designed to select rows among your data, where filter, you select the rows by certain conditions. So let's give an example. So let's say that you're interested in taking data where multiplying 3 columns, you find that, let's say it gives you some sort of volume, and you're interested in that volume above a threshold. In this case, I just use the number 10. So a way that this gets called in R is typing in the name of the data frame, and then these functions that you see here, this is a percentage for its percentage greater than percentage. This is kind of calls this function to applies it to that object, the following description. Filter, and then in parentheses is our condition, basically. So the idea is that this gives a filter within a data frame to call, and we can actually assign this as an object to call a secondary object based off of a data frame that just contains our filters with our threshold. So it's just a way of letting you take data and coming up with different slices of it, basically. Other things you can do with Dipler, subset, you can create, again, a subset of data. And you can do that again by having the subset function and then again having a condition in there for maybe a column or some sort of calculation. Merge can help you in terms of merging and combining data frames. So you may have 1 or 2 data frames from different sources you want to combine. And then you have mutate and arrange. I'm going to talk about these real quick. They can create a new variable at a current level. Mutate is just adding a new variable to your data. There's maybe something so that's basically equivalent of adding another column. And then arrange can also help you in terms of arranging the order of the observations in a variable in an increasing or decreasing order as well. So you can have, maybe say in our example from cars, you might have horsepower and you want to arrange the observations from least horsepower to greatest horsepower, and arrange will help you do that. And then also within one thing about RStudio is in the upper column or upper panel onto the right, you can look at the environment and look at the variables you have from there as well too, and that can help you in terms of what's being imported into your environment as you are working with data. Now another function. How am I doing so far, everyone? Doing okay with you? And you can type in as we go. So another function that you want to think about. Okay, perfect. Thanks, Aaron. Thank you. So another thing you want to keep in mind is there's a function called stringer, or a library called stringer, and this is more for characters basically. And this is just a few functions that are built into this. And by the way, I mentioned about crayon, and I want to back up and mention one quick general thing. Each library I mentioned has a document with it. So when you go to crayon.org and you look for your function or your library, Crayon will return to you not only a web page with the zip file to download and put into R, but there's also a working document. Every library has a document that lists the functions that are associated with that library. So you get a sense of what those functions are, what they're used for, and an example. And you get, so it pretty much comes as a PDF. So every time someone is publishing a library, they have to have that document in there. So just keep that in mind. So these are just a few functions I'm showing with each library, but there's more for each one, and you can go back and look and import into you can download those PDFs as well. Okay, thanks, Jessica. Okay, pacing is good. Thank you, Jody. Thank you. So stringer is designed to inspect observations for characters. So this is basically text, basically. So a couple of quick ones that you can use. Stringer direct, you can use to inspect each column for the type for characters, basically. And then stringer has a couple of functions that lets you modify the string. And you can modify this if there's some sort of subtext that you need to add. or in some cases like stringer subset, returning character elements that match a given regular expression. So subset can help you if you are looking for, let's say for automobiles, for example. In one of the examples I had earlier, there's a listing of engine type, and let's say that you're interested. Let's say Jody is interested in diesel engines, for example. Well, one of the things that and she gets this sheet from her manager, and in the sheet it's accurate, but the problem is that it's all in text, and some cars are being described with maybe with a D, letter D for diesel. She can set up a string subset within R where each time that she gets an update, it can identify the character elements within a column. So you can set that up to identify if that diesel comes up normally. So that kind of gives her a way of working efficiently to help capture if that comes up, and she can make adjustments into her model, or at least say, hey, if I'm dealing with diesels here pretty quickly. That's kind of the idea behind Stringer. Let's see, funModeling. Now, this is a little bit more for exploratory data analysis. You'll hear that quite a bit, and that's kind of sort of what we're doing here in a way. EDA is more of the end result is that you're using it more for a regression or maybe for specific models, but the same process is applied here. funModeling can help you in terms of trying to get some sort of numeric distribution among your variables. So, for example, this is a graph showing a count on for each variable for diamonds. This is for carat, the depth, and pricing, for example. I forgot what X, Y, and Z is for, but so forgive me for that. But the idea is that you might want something graphical to kind of help you figure out if a certain you know that there's this goes again to what you know about your numbers. If there's a certain number of times that a certain value is showing up all the time. So for price, for example, like right here, right in this example, we notice that there's quite a few of them, maybe 20 that are showing up near the $400 price. But then we have a small distribution that is around 350, for example. So the idea with this is that you're graphing kind of get a quick view of which from the observations under a variable, if there's some sort of skew or some sort of way they're being distributed that's not as even, or if there's some sort of skew to it. It kind of gives you a quick way of viewing on it. And it's being much designed for numeric variables. That's something to keep in mind. And then you can use something like that to help you in terms of for frequency. You can get, if you want something much simpler, just saying the frequency of how many times a number comes up. There's a frequency function. So for example, here, this is empty cars you'll see that example a number of times where each time that it's a database that comes within R basically, and there's a few some of these are really old, like MT cars stands for Motor Trend Cars, but it's referencing AMC Javelin, I believe AMC Hornet. There's a Ferrari Dino. This is cars going back to 1970. So it's a little older, but each library that you look for within R, there's usually a database that's included with it to help you practice through. So if you're trying to kind of practice and figure out how to use a function, there are some examples. A really good library will have an example data built into it, and you can apply those functions easily to it. But in this case, for frequency, we're taking the MT cars, which is built into R, and then you see there's a $sign, MT cars, $MPG. That MPG is referencing a column in MT cars called miles per gallon. That column is called MPG, but for miles per gallon. And so the frequency distribution is just showing which vehicles are getting 30 miles per gallon, 22 miles per gallon, and so forth. And just gives the bars are corresponding to the number of observations that have that miles per gallon, basically. So it's just another way of viewing it. Let's see how we're doing here. Okay, so got a couple more slides here. I'm going to try to get us through here real quick. So now managing your environment. A couple of things to keep in mind. There's most times within R, each time that you're assigning an object, each time that you're assigning uh, some sort of variable or object to a variable, it takes up memory space just like any other program, just like you would for JavaScript. And most times it works very well. There's not really a big problem for this, but there's going to be some times where, in trying to figure out if a calculation is working, what you don't want to see happen is having an object that's being that doesn't update or somehow is not, is still stuck within calling maybe some sort of old data field. So there's a couple of things you can do in your environment to do a quick check, just to make sure that's not a problem. LS will list out the global objects that exist within your environment. And then you have what's called remove. You can remove objects if you find that there's objects that are still being called. Most times you can look at that within RStudio. You can look under the environment tab to kind of see what's going on. But then on the prompt, you can type in remove to remove an object. There is a library called RenV, RENV, that not only, and this is really good if you're sharing a project with somebody or with a team. It's recommended because there's a lot of times when people have libraries, dependencies, and dependencies are the libraries basically. You want to make sure that when you're sharing with people that they have the same libraries that you worked with. So one of the things you want to keep in mind is if you're sharing with people, you may want to look at the library RENV and make sure that's included. So because then you can use functions from there to help check to make sure that your team everyone's not only using the same libraries, but also the same level of libraries. And that can play into any problems you're having with your calculations if the objects are not also a problem as well. So I mentioned, again, what we're talking about here, all this is called exploratory data analysis. And I won't stray on this too tightly, but just kind of the general idea is that you're reviewing statistical characteristics of your data. It's a precursor for your predictive analytics, and maybe some sort of data visualization. Checking for NAs, unusual values, extreme outliers, adjusting rows and columns, and you're spotting any anomalies, basically. And again, this is a mix of what your experience is telling you to do, as well as just kind of what's in the data, basically. So that's pretty much a big part of this. And what you want to do is what you should end up with is some data that in some sort of data frame or data table that represents what helps you to answer or ask the right operational questions related to the data. That's what it should be helping you to do. Real quick on debugging here. R is like I said, like any other programming language, it's one of those things where if it's very simple, it's not that hard to go back through and find errors, but as you type more and more, you do need to debug, and there are some functions that can help you to do that, and there is a library that can help you to do that. If you need to comment, first of all, within maybe a script, you can use the pound sign and then type comments into the type your comment into the script. And a lot of times people do that to describe a little bit about what they're doing from below. Now, if you are running a lengthy program, you can click a line within RStudio or to add or remove a breakpoint. That's what debug, browser, and traceback allows you to do, basically. And there's some variations on browser, basically, but the idea is that each one of these are designed to stop the program if there's a at a particular point, depending upon what you're calculating and what you're trying to go through. There's one also library called rlang, which has a function called last trace, and that's actually a really good. It kind of supports the traceback a little bit. Traceback is literally just going back and seeing like what built up before the error that you run into. Last trace can also help you in terms of the number of objects and other things that got associated with that trace as well. Now, lastly, so you've done your project, you've done your data, you've done some debugging, and you may, again, have a team that you might want to share your code with, but let's say you have business analysts or other people who are not as interested or as enthusiastic about R programming as you are. That's where Markdown comes into play, and you'll see this mentioned a number of times. I believe there's a Markdown for there's different programming different programs that use Markdown at some level. R Markdown has the word R put in front of it, and I'm not sure if there's a major difference. Some of it may be a little bit that might be a little bit more beyond the scope of this, but the idea with the Markdown is that it's pretty much a book that runs code and has your comments in it and allows you to share in different formats, a PDF format, a Word format, or HTML format, and lets you share your project with other people who are just more or less interested maybe in the output, but not necessarily needing to see every piece of data that went into it or some of the things that you did for debugging, basically. And it's a really good way of getting a report out the door while you are working on code further, basically. It's a separate file format. It's an RMD. It's pretty easy to set up within R, basically. And then you can have code that can show or run a demo right within the document as well. So the idea with this is that you go in R, and right where you save your project, there's also a selection for R Markdown. And again, you can give a title, give the author's name, and it pretty much, in fact, it uses a library called knit. And I'll go back and double check. I think that is you'd have to go back and download. But the idea is that you can add. I'm going to make an apology on this slide here for a bit, but I'm not sure why the text got hid. But what you end up with is this document that allows people to kind of see a little bit of the some of the description and some of the code, and you can have chunks where you can add or insert different variations of code and commentary. And then you can host a Markdown. The neat thing about this is that I'm going to scroll back here for a second. I mentioned about HTML. You can host this on a web page for somebody to take a look at or make it convenient for a team. And there's a couple of them that are free. rpub.com has a free one, or you can actually create a Shiny app based off of this and have it as an app as well. So there's a couple ways you can host this and have this available. And then lastly, I want to talk about a little bit about keeping data in mind in terms of privacy. A lot of times when you're, depending on the types of observations you have, you may have some things that are involving that maybe data that's provided from maybe a community of users that you are responsible for. Keep in mind that as you are saving data, and you may want to think about, what's the length of time that data is being held. Most of the regulations like GDPR and so forth are usually it's a lot of detail, but most of the detail, if you really go back and look at it, looks at how long you're holding the length of time that data is being held. So you want to think about as you're ingesting data, if it's coming from a spreadsheet just as a trial, it's it may not be a big deal, but if it's dealing with something that deals with people or some sort of registration, I'll give you a quick example. Red Roof. I remember the manager, I can't remember the manager's name off the top, but it was interesting. They had to comply to GDPR, which is actually for European privacy regulations, because even though they don't have any hotels in Europe, and the reason why was because in their databases, they had visitors or customers who would come to the States and provide information for their customer service, basically. And so the idea is that if you, according to European regulations, if you are holding on to that data, you need to, have a process in place, saying that, there's an opt-in and a clear opt-out. So whenever you're dealing with data, if it's something that that you're dealing with in terms of maybe customer data, It could be something, anything that deals with a person and their personal identity. You need to really think about length of time for that data is being held, how that data was being acquired, what was the permission process, and then you need to think about how you would communicate updates to your team. And that's a lot of the stuff that I talked about today can help you to do that if you organize it around that. Basically, just some in terms of something you can work out with a manager or a team in terms of communication. Okay. So real quick summary, create a project. You can do an individual script if you're just trying things out, but eventually you want to think about is creating a project. So that way you can save associated data and maybe even multiple scripts that for something that you're trying out to do to make it convenient for yourself. Identify your observations that are going into your data. Think about how they're being imported. Think about libraries you want to use. Manage your environment, and that can get into a couple of things in terms of cleaning your objects, and also in just what I just talked about, a little bit in terms of what types of data that you have coming into it if there's a privacy issue. And then keeping, if you want to update other people in your team, a good workflow is thinking about maybe using R Markdown to share code and comments with others who wants the results, but maybe not necessarily all the dirty laundry that goes into the code. And with that, that is the end of my presentation. I'm going to also note for you as well too, at the end of the slide, I'm not sure how they're going to do the slides here. I've also included, I mentioned about CRAN quite a bit. I want to talk about a couple quick things. I've included the link for CRAN so you can go back and take a look at. There's some variations on CRAN. Microsoft is very big on R, so they have what's called MRAN, which is their version of CRAN. But CRAN is pretty much like the basic piece of it that you can use. I've also mentioned there's another great library called DevTools that you use for your GitHub for installing the GitHub there's GitHub functions for the DevTool package. Practice data, you can look up data sets within R. This is automatically comes with R. If you type in library data sets, it'll give you a list of data sets you can practice on. Again, this is where you get MT cards and so forth. Operators, to just kind of put edit operators here just for convenience. And if you're unsure of anything, there are some help functions that are built into R, and I put that at the end here. And I mentioned a few packages, and there's other packages that Data Explorer, Psych, and XDA that can be helpful. And these are more helpful if you're trying to get more into the statistics of it. Are there any questions? Let's scroll back up and give everyone a couple of minutes here. Okay, Jody, in one of your examples, you mentioned a count of infinite values. Is there an infinite symbol for observations analogous to, okay, or would infinite just be the result of a calculation? That is a good question, Jody. There is a, let's see here. I can explain this very well. Infinite, I think I kind of know where you're going at. Infinite symbol. If you go back, let's see here. Where was it? Yeah, funModeling. Okay. funModeling, I think, yeah. This gives a quantity of infinite values. I would go back and try with funModeling first, because you'll get a quantity of, if there's it'll tell you if those things exist and what percentage at least. So that's would there be just the result of a calculation? Yeah. So I would say this function back here within funModeling can give you, it's basically, it's pretty much a function that you call that will go back and examine within your data. So it's not something you have to build or calculate on, but at least can give you kind of a starting point to see if that's within your data before you start, let's say that for your manager is looking for click-through data, maybe click-through rate, and you don't want to have any infinite values in there. funModeling will help you see if there's infinite values that are coming from, let's say it's data from Google Ads, and you want to make sure that's not in there. Because if it is, it might be some sort of error from some sort of click or something that wasn't set for a digital ad. But funModeling can help you to kind of catch and see if that is if that's appearing within the data. And then later on, as you're, and I didn't go into automation too much in here. I kind of kept it very basic, but there are ways of modeling and doing maybe some automation. I'm hoping that there's a lot with CI/CD that's going on right now. I'm hoping that I'm actually going back through and trying to understand the automation and how to set it up within R as a script. So I'm hoping I can do. What does infinite look like as an observation? Inf, or is that even possible? It would. Let's see. I don't have a setup off the bat. Probably, you would probably see something like a. That's going to vary basically. Some of it, no worries. So I would say a lot of this is, and most of this I've set up has been around, think of it as I would say even if it's something like maybe a null or something that it would maybe a character that just did not get recognized pretty much. So okay, all right. Any other questions? And thank you, Jody. That's a great question, by the way. No others? Okay. I'm going to say thank you. Thank you for sitting. I know it's kind of about 9:40, it's about 10:47. So I know we went a little long. But I want to say thank you. And you're welcome. Thank you. And I'll go ahead and make sure the slides are available. And it has my contact information. I'm also on LinkedIn. Feel welcome to connect. If there's anything I didn't cover or anything else, feel welcome to connect and ask questions. Thanks again, everybody.